I'm going to show you how to do more precise calculations by taking into account forces. We're going to be talking about the normal force and the force of friction. Force of friction always opposes the movement. So in the case of the previous video, you saw that the friction of the handrails uh, will oppose the movement of the book, and all that energy will be transformed into heat energy. So at first, let's just look at the difference of how this works. If we do it like we normally do it, we'll have that in point one, gravitational energy equals to kinetic energy, and we'll have that mgh mgh equals to 1/2 mass times velocity squared. The masses cancel out, and we'll have that velocity equals to the square root of 2 times the force of the acceleration of gravity, which would be 10 meters over second squared, times the height, which is 0.5, and we'll have a velocity of 3.16 3.16 meters per second. This without taking into account the force of friction. Okay, now if we take a look at the diagram, we know that we put the x and y axis next to the surface, so the weight will always point towards the middle of the earth, and it will be divided into components. This is a vector into wy, weight y, and weight in x. We know that the force of friction equals to mu times the normal, and if we wanted to do work of friction, we just multiply the force of friction times the distance, which is going to be this distance from point 1 from point 2 point 2. So we're going to have that n minus wy, because we know that up is positive in this case, is going to equal to 0 because there are no other forces acting on this. So n will equal to wy, n will equal the weight times the cosine of 35, because here this angle is equal to this, and wy would be equal to the cosine of 35 times the weight. And then we know that weight is mass times gravity times the cosine of 35. So now we're gonna do this again, but taking into account the work done by the force of friction. So we're gonna have gravitational energy equals to kinetic energy. Here we go, kinetic energy plus the work done by the force of friction. Okay, so we're gonna have mgh equals to 1/2 the mass times velocity squared plus, I'm sorry about that, plus mu, which is for the coefficient of friction between metal and plastic is 0.325, mu times the normal, which is mg times cosine of 35, m times g times cosine of 35, times the distance. So we can see that all mass cancels out, and then we just solve for b. So let's just replace g times h would be 10 times 0.5, and then we subtract to that the mu, which is 0.325, times gravity, which is 10, times the cosine of 35, times the distance, which is 1.03, we can see here. We subtract that, equals to 2.25. We square that. I mean, no, we don't square that. We multiply it by this 2 over here. Yeah, we multiply by 2, and then we square that answer. So we square the answer, and we get that the velocity is 2.12 meters per second. So we can see there's a huge difference between doing the relationship between gravitational energy and kinetic energy without taking into account the work done by the force of friction, which will give a velocity of 3.16 meters per second, while in reality it actually gives us a speed of 2.12 meters per second. Thank you.